Well, hello guys. So this is another CTF, but this time we will be dealing with packet captures. And here is the details of this challenge. So we are a company specializing in hosting web app through KVM virtual machines. And then over the weekend, one of them went down, uh, and the admin feared this might be a result of malicious activity. So they extracted a few logs, including the attached pickup, and asked us to investigate this question. So we will use these helpful tools in analyzing and answering the questions. So without further ado, let's move to question one. Okay, so after you downloaded it, open it in your analysis VM. First question, what service did the attacker use to gain access to the system? So we have here SSH. Let's go to our analysis VM. Notice here I've opened it using Brim. And then what's good about Brim is it has built-in queries. So basically you just need to go to activity overview for this question. And notice here we have different categories. We have con, SSH, connection, files, HTTP, and so forth and so on. So how about to investigate first? So to investigate a certain category, simply right click and pivot to logs. So example con. So can we see any successful attempt here? Perhaps let's try the other one, SSH. Simply right click again, pivot to logs, and see here it's already sorted. And notice here these two starting event stand out, having an auth success equals true, meaning it has a successful SSH authentication. So this probably is the entry point of the attacker, which really fits as our answer here. So as you can see here, SSH. Okay, number two, what attack type was used to gain access to the system? So recall on question one, we have seen multiple SSH attempts and only two were successful. So meaning out of the 60 plus, uh, there are around almost 50 plus or 60 plus failed attempts. So this is definitely a brute force attack. And then what was the tool? Next question, what was the tool the attacker used? Uh, if you will Google out SSH brute force tools or SSH password brute force tools, definitely you'll see top tools like Hydra and the like, and actually Hydra is the answer. The next question, how many failed attempts were there? So if we'll go back here, notice here, stand corrected, there are 54 SSH attempts. And then remember we investigated it, pivot to logs. Out of 54, only 2 are successful. So that gives 52 failed attempts. Okay, number 5, what credentials were used to gain access? So refer to shadow log and sudoers log. So actually number 6 is also related, so we'll tackle it together. So the question 6 is, what other credentials could have been used to gain access? Also have sudo privileges. So they have the same hint and the same materials to be used. So let's go now to the, notice here the shadow log. The shadow log and this one. Okay, here's the shadow log and the original shadow log, and here's the sudoers log. Okay, side by side. So notice here in the In the sudo slug, these are the accounts that have sudo permissions. Guest, manager, Shan, Roger, and Pierce. So what we have to do for number 5 and 6 is crack the fast password hashes for these accounts. So to do that, we'll go to our Kali machine. The first thing you need to do, take for example, let's say for manager. What we need to do first is copy the hash, this one. Copy the hash and put it in a file. So I've already saved it here. So you could do it using echo command like this. Echo, this one. Save it to a file, user.hash, and simply press enter. Okay, then you could check if it's properly saved. The single quote should be gone there. And then the next step is to run hashcat against that. So this is the command for the hashcat. So we will use -a0 space 0 for dictionary attack. Oh, sorry. Should be user.hash where we save the hash of the manager account. Okay. And then space is the rocku.txt, the password list, possible password list. And then -m 18 is the type 6 password hash. Okay. Simply run this. Okay, we are getting this one. All hashes found in path file. Use --show to display again because I've already run this again. So, okay, just to show you that it works from scratch. Let's save that to another file. Echo manager.hash. This one. Then let's run it again. Manager.hash. Okay, it's already found as well. So if you encounter this error, simply append --show, meaning it already was able to crack the hash inside that, and you will get this. So for manager, this one, the value of the password for this hash is forgot. Okay, and you have to crack each of the accounts in the sudoers here for Roger, Sean, Pierce, uh, and you will eventually get this one. So manager, we have forgot, and Sean, you will get Spectre. Okay, number 7, what is the tool used to download malicious files on the system? And actually it's related again to number 8, how many files the attacker download to perform malware installation. So let's go back to our PCAP opened in Brim security. So we'll again go to activity overview, and since we are dealing with file downloads, let's observe the HTTP packets. So here, simply right click, pivot to logs. Okay, and then we can sort it by time, clicking on the time column. So now it's sorted chronologically, oldest to newest. And then observe the column RESP MIME types. So it's on the last column. So notice here the first packet is the one that downloads the executable, a malicious executable. So you can right click here, open details, and you can focus on the user agent. Notice here it used the wget utility to download the malicious executable. Okay, that's how we get the wget. And then for the number 8, how many files were downloaded, executables were downloaded for malware installation. So going back here, notice the REST MIME types. There are three related to executables: executable, XObject, shell script, and the rest are image downloads. So that's how we got the answer 3, right? Okay, next, what is the main malware MD5 hash? So we got this. So let's go back to our analysis machine. Recall on the very first packet, uh, downloaded this executable. So we have to extract the executable, and there's no easier way than to use network miner. So here, just open the packet and go to Files tab. Notice here, it extracted each files chronologically. So from packet 1 and onwards. So this is the packet 1. So it extracted 1.html from that, which is actually an executable. So next thing is to right click and click on file details, and you will automatically get the MD5 hash. So you could select all and copy it in order to extract the hash. Okay. Okay, and then what file is the script modified? So the malware will start upon reboot. So this is the answer. This is actually a persistence mechanism within Linux. So any modification added here will take effect or will persist even if the Linux box was rebooted. Okay, so let's go back. So recall here in our network miner, we have extracted 3 executables on the first 3 packets. So the next thing to do is to do a strings extraction on those 3 executables using this command. So I've executed here strings -a space the file, and then redirect the output to a text file, and I have so here's the finished result. So for one and first and the second is are actually pack executables. Notice the UPX. While the third we can read no problem. So here we actually found the answer. So it's echoing this echoing and appending this config to etc.rc.local. So, okay, so number 11, where did the malware ship local files? Okay, so found here var mail. I'll continue up to 13 because if you'll notice, we will be inspecting the same executable. So for 12, what is missing from ps.log? ps.log is like a task list in Windows. So this is the missing entry there because the later I'll show you. So, and then what is the main file used to remove this information from tslog? Okay, let's address them one by one. Let's go back to the remember the 3.text, the 3.html executable. We found the script. This one is being used for persistence mechanism to survive reboot. And then for the question, where does the malware store the process? So store the malware. What process does the malware inject itself or store itself? It's actually here. This is the process being used, var mail mail. Okay, and since it's and all the malware is being stored in actually in the var mail. This is a default Linux directory. And then, as you observe in the PS log, since this is the malware process, let's observe the ps.log provided. Notice here, we should expect the var mail mail to be present here in the task list of the Linux machine. As you can see, it's missing. Var mail mail, it's missing. So what behavior is that? Hiding itself from the process tree. It's a rootkit behavior. Okay. So what 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 did what did the malware use to hide itself? So let's go back to the script. It actually uses this one, the sysmod.ko, to hide itself. Alright. Okay, number 14. Inside the main function, what is the function that causes requests to those servers? So the hint here says, oh, sorry. Oh, there's no more hint. Anyways, the hint here says we need to unpack the first or the main executable and observe the main file, and specifically this function, which points to request to outbound CNC servers. And it's actually related to the next question. One of the IPs the malware contacted starts with 17. Provide the full IP. Okay, so let's go to the analysis machine. Okay, remember these are the extracted executables. So what we need to focus on the first one, the one.html. So since it's packed, let's use a unpacker. So I've actually downloaded the UPX already here. So let's copy it here for easier navigation. Then let's run cmd. So we will unpack it using this command upx .exe-d, then the executable we are to unpack, which is the one.html. Okay, notice here, this is now 27 kilobytes as compared to the original one of 11 kilobytes. So from 11, we have unpacked it and expands its content. Thus, it gets bigger to 27 kilobytes. So with that, we can now open it using any disassembler. So we'll open it using IDE Pro. Okay, all files, choose all files to show the one.html. And we know it's an it's an Linux executable, so select it, okay. And you can see since it's unpacked, it will now show uh, the functions of this executable. And we can also now see the main. Okay, so double click on it. And it says there we can see a request file. See, it's now calling a request file function. So in IDE Pro, you can just double click on a function to follow it. Notice here the function. You can now see this one, uh, which is actually equivalent to this one, wget, meaning it's contacting a URL. So thus, this is the answer. And then, on the next question, it says here, one of the IPs malware contacted starts with 17. So this one, let's go back to the main function. And notice here, the main function, it has an ABDR variable. So if we will follow it, double click on it, it will actually take us to this view. And as noticed that ABDR contains these values. And since the hint says it starts with 17, this is our answer. Alright? Okay, number 16, how many files the malware requested from external server? So we have here 9, so how do we get this? Let's go back to our Brim view. If you recall, these are all HTTP requests, and let's sort it by time. We'll sort it by time. Remember, the first three are the malware executable or installation files, and the rest are the requests after the malware installation. So we'll just have to count this image request, 1, 2, 3, and it's totaling to 9. That's how we got the answer. And then for the last one, what commands the malware was receiving from attacker servers. So command separated in alphabetical order. So this one, we are to observe the main, but the hint here actually starts with letter N and R. And if you're familiar with assembly language, this nop and run are the common commands in the assembly. But I don't know how to derive it in the IDA Pro. So anyways, we got the answer. So we go to main. It says there, check the process message. Yeah, so probably we need a debugger to view that nop and run commands being called by the executable being executed. But anyways, hey, uh, congrats on finishing this challenge. Okay, till next time.